Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium. Today in this session we are going to learn about buffer solution. Let's start. So what are buffer solutions? What are buffer solutions? Let us see. Buffer solution means solution which resist. You know what is meant by resist? Resistance, opposing force, or opposing. The nature of opposing is called as resist. Resist the change in pH on long standing or on dilution or on addition of small quantity of acid or base is called as what? A buffer solution. Okay. So for example, let us take here there is a solution. There is a solution which I am calling it as buffer solution. Okay. Here there is a solution. Okay. Now, when do I call this solution as buffer solution? When it is left for long time, its pH should not change. Its pH should not change. It should not change means there can be very slight change. Okay. So the solution, every solution will have some certain pH. So it is having certain pH. When it is left for much time, we find the change in the pH. There is no change in the pH or very small change in the pH. Okay. So actually when it is left for long time, some solutions, there will be much change in the pH. But this is a different solution where it will resist the change in pH. It will resist the change in pH. Such a solution which is opposing the change in pH. So what is buffer solution? Buffer solution. Solution that opposes, resist. Resisting means opposing. Resist the change in pH. Yes, there will be some change. When there will be some very slight, very minute change in the pH happens. When does it resist the change in pH? On long standing. What? On long standing. On long standing means when it is left for much time without any disturbance. The second one, on dilution. That means when you pour water into it, you know what is meant by dilution? You know what is meant by dilution. So when you add some water into that buffer solution, actually on dilution, if it is not buffer, if it is whether acid or base, there will be much change in the pH. As it is buffer solution, as it is having tendency to resist the change in pH, on dilution, on addition of water is added. On dilution means, what is that meaning? Addition of water, addition of solvent. Here we are adding water. On adding water, this solution resists the change in pH, opposes the change in pH. Okay. Next, on addition of small quantity of acid, on addition of small quantity of acid or base. If you add small quantity of acid into this buffer solution, or if you add small quantity of base into this buffer solution, there should not be any change in the pH, because this buffer solution, there should not be much, there can happen very small change in the pH but not much change, because this buffer solution has a tendency to resist the change in pH. So overall, what did we understand? Buffer solutions are the solutions which resist or oppose the change in the pH on long standing or addition of water, that means dilution, or on addition of small amount of acid or a base to it. Such solutions are called as buffer solutions. In the body also we have a buffer solution. Blood. In the blood we have buffer solution. We eat different types of foods. We drink water. We eat acidic foods. We eat basic foods. We drink water. So much changes are brought in the blood, but still the pH of the blood remains constant. All the organs in our body will work at a certain pH. Every organ in the body will work at a certain pH. If the pH is changed enormously, if the pH changes enormously, then the body organs will get damaged. So this blood is maintained at a particular pH. Blood is acting as a buffer, though you add water, though you drink water, though you eat acidic foods, though you eat basic foods, it will resist the change in pH. So natural buffer, very good example of natural buffer is blood. Are you getting this? So here, let us see another definition, another way of speaking buffer solution. What is that? A solution which reserve the acidity or alkalinity. There is a solution. For example, its pH is equal to some 5. It will try to maintain that pH is equal to 5 when on adding water or adding a small amount of acid or adding a small amount of base, it will try to maintain, that pH. There may be very small changes like 0.01 pH change, 0.01 pH change, but there will not be much change like 0.6 or 1, 2. That huge change we don't find in the case of buffer solution. Okay, so buffer solution will reserve its acidity or basicity. If the solution is acidic, it will maintain its acidity. If the solution is basic, it will maintain its basicity or alkalinity. And that solution is called as what? Buffer solution. There will be change, no doubt about it. But the change is very minute, very small. We cannot say that there will be no change. It will maximally try not to change the pH. It will try. But sometimes there can be very small changes. Very small changes. That does not affect. Okay. Next, the resistance offered by solution to any change in pH value is called as what? Buffer action. Buffer action means it is offering resistance to change in pH, and that resistance offered is called as what? Buffer action. So there are two types of buffer solutions. What are those two types of buffer solutions? Let us see. One is acidic buffer, another is basic buffer. Okay, buffer solutions are of two types. Buffer solutions of desired pH are of two types. One is acidic buffer, another is basic buffer, or acid buffer or base buffer. Okay, when can we say that a buffer is acidic? Acidic buffer solution. When can we say that the buffer solution is acidic buffer solution? So now we are taking a container. Okay. In this container, if it possesses weak base, what is that? Weak base plus salt of weak base. Salt of weak base with a strong acid. Strong acid. Okay. See, a mixture of weak acid. So what is this, sir? Basic, that will be a basic buffer. Now we are speaking about the acidic buffer. Weak acid plus the salt of weak acid with what you can write a strong base. What is that? Strong base. SB means strong base. Okay, for example, let us take here we have one acidic buffer. Acidic buffer. Now let us see here CH3COOH is reacted with whom? NaOH to give you what? CH3COONA plus H2, right? Now, before the reaction, time is equal to 0. How many number of moles of CH3COOH are present? For example, I am taking it is 0.5 moles per liter concentration. Okay. Now, what is the concentration of NaOH? It is taken as 0.1 molar. Now, there is no concentration of salt and acid. Now, you are mixing these two. That means after reaction. What is that? After reaction. So reaction occurs between, what is this? This is acid and this is base and this is salt and water. Reaction occurs between these two because they are acids and bases. From the equation, you can find that, what you can find from the equation, you can find that 1 mole of acid react with 1 mole of base to form 1 mole of salt and 1 mole of water. So 0.5 moles are given here. Here it is 0.1 mole. So that means this will completely react. Which will completely react? NaOH will completely react. So 0.1 minus 0.1, there will be no base. Now this will react 0.1 minus 0.5 minus 0.1, that is equal to 0.4 moles remains. Here 1 mole base completely reacts. How much salt is formed? 1 mole is formed. That means 0.1 mole of base is reacting. So how much salt will be formed? 0.1 molar. Okay. Anyway, in water it dissolves. These all things dissolves. So we are not bothered about water, right? Water is a solvent. Now, in this container, what is present? 0.4 mole of acid. And salt, how much you are having? 0.1 mole of the salt. Only these two are there. Such a solution is called as what? Acidic buffer solution. What is that such solution called as? Acidic buffer solution. So acidic buffer means the solution. It is a mixture of what and what? Weak acid and the salt of that weak. See, this is the salt. Salt of that weak acid with strong base. NaOH is strong. See, CH3COOH is what? CH3COOH is weak acid. Weak acid reacting with what? NaOH. NaOH is what? Strong base. To give you what? CH3COO Na plus H2O. This is salt. The salt is from whom and whom? Weak acid and strong base. So this weak acid and strong base, when they react, you get salt. So that salt and weak acid mixture is called as acidic buffer. It is called as what? Acidic buffer. Understood what is acidic buffer? It is a mixture of weak acid and its salt. Its salt means salt of that weak acid with whom? Strong base is known as what? Acidic buffer. The best example in all the competitive examinations given is this acetic acid and sodium acetate. A mixture of acetic acid and sodium acetate. So what is this called as a sodium acetate? Sodium acetate. Okay. What is this acetic acid? So mixture of acetic acid and sodium acetate is an example of what? Acidic buffer. It is a mixture. It is an example of acidic buffer. Right? Now there are different examples. Other examples are also given, right? Let us see. Phosphoric acid. What is this? H3PO4 is a phosphoric acid. Phosphoric acid is a weak acid. Phosphoric acid is a weak acid, and NaH2PO4 is salt of this phosphoric acid with the salt of this phosphoric acid with the NaOH. Let us see that. Now H3PO4 is reacting with the NaOH, gives rise to NaH2PO4 plus H2. This is balanced equation. So this is what weak acid and this is salt. And if these two are present, what must be present here? What must be present in this mixture? What must be present? H3PO4 plus NaH2PO4. These two must be present. Understood? These two must be present. So then that is called as what? This is called as what? Acidic buffer. Acidic buffer. Understood? Who must be present? Weak acid and the salt of that weak acid with a strong base. In the same way, borax, you are given borax, tetraboric acid, H2B4O7 is tetraboric acid formula. Borax formula is Na2B4O7 10H2O. Okay, so this is weak acid, tetraboric acid is weak acid, and borax is the salt of weak acid with a strong base. Right? Even see here, this is salt. This is acidic in nature. Acidic in nature. So this mixture can also be considered to be acidic buffer. Acidic buffer. Next, phthalic acid. So what is phthalic acid formula? So this is phthalic acid. C double bond O, OH, C double bond O, OH. Phthalic acid. Weak acid. What is that? Weak acid. So potassium hydrogen phthalate. Formula of this potassium hydrogen phthalate is like this. C double bond O, O, K, C double bond O, OH. So potassium, hydrogen, halate. Okay. So this mixture, this is salt and this is acid. So this mixture is also called as what? Acidic buffer. In the same way, this is H2CO3 is weak acid and this is salt. This mixture is also called as acidic buffer. So these are all examples of acidic buffers. The best example which is asked in the examination is what? Best example which is asked in the examination is acetic acid. What is this? This one. Acetic acid and sodium acetate. Acetic acid and sodium acetate. A mixture of acetic acid and sodium acetate. Okay. Next. Yes, a very common acidic buffer is prepared by mixing equimolar solutions of acetic acid and sodium acetate. A very common acidic buffer. Acidic, normally we have seen acidic buffer. A common acidic buffer is prepared by mixing acetic acid. What is that? Mixing acetic acid. So CH3 COOH, sodium acetate CH3COONA. Equimolar, let me take it as 0.5 molar. Now this is also 0.5 molar. So that is the meaning of this equimolar. So when you mix these two in equal moles, equal concentrations, you can take equal concentrations or equimolar. So when you mix these two, maintaining the equal molar solutions, then that is the common acidic buffer. Okay. So acetic acid is very slightly dissociated, while sodium acetate being a salt is almost completely dissociated. So now, what do we have in this? A mixture of solutions. What do we have? We have two components. What are those? One is CH3COOH. It is a weak electrolyte. It slightly dissociates. That means it converts into CH3COO minus plus H plus. As it is weak, we have mentioning that it is reversible. It has both forward direction reaction and backward direction reaction. And in the same container, we do have sodium acetate also. What we can write CH3COONA. It is strong. It is strong. Okay, because it is salt. When it is salt, it completely dissociates. It completely dissociates into CH3COO minus plus Na plus. Okay, so the mixture contains molecules. Which molecules? Undissociated acetic acid molecules. Okay, what you can write CH3COOH molecules as well as acetate and sodium ions. Acetate ions and sodium ions. Here, what you need to remember is that it is weak. Who is weak? Acetic acid is weak. It does not dissociate much. When 100 molecules of acetic acid are kept in when 100 molecules are there, it dissociates into acetate ion and H plus. Just 3 or 4 molecules will dissociate. That's it. Are you getting this? Just it depends upon degree of dissociation, and the degree of dissociation for acetic acid is very less. It is weak acid. It dissociates very much less. Are you getting this? So these acetate ions, if you see, these acetate ions are maximum from the salt, because salt is strong and it dissociates completely. Dissociates completely. So all the acetate ions are from salt. We can take it as all the acetate ions are from the salt, because acetic acid is weak electrolyte. It does not dissociate much. Let us take 100 sodium acetate molecules are there. 100 dissociates. So how many acetate ions are formed from sodium acetate? 100. And 2 acetate ions from acetic acid. So totally 1 or 2. Among that 100 are from whom? 100 are from sodium acetate. That is the reason why we are mentioning that all the acetate ions are from the salt. Are you getting this? So let us see. How does this act as buffer? What is the buffer action? Let us see. What we are speaking about? We are speaking about buffer action. How does it act as a buffer? Up to now we have seen it will act as a buffer. It will resist the change in pH. Then how does it act as a buffer? See, we have a buffer solution, right? What does it contain? It contains CH3COOH and CH3COONA, right? So CH3COONA dissociates into what? It dissociates into CH3COO minus Na plus. So we don't have CH3COONA. What has happened to CH3COONA? It was dissociated into what? CH3COO minus and Na plus. Are you getting this? Okay. And most of the molecules of acetic acid are not dissociated because it is weak. So now what you are doing? You are adding some acid. H plus is added in the form of HCl. Only some HCl is added into this. When HCl is added, if it is not buffer solution, it will release H plus. If it releases H plus, it results in acidic solution. Its pH changes. When you add HCl, it dissociates into H plus and Cl minus. Now what happens? More number of H plus are released. When H plus ion concentration increases, automatically the pH decreases. So there must be much change in the pH. But this is not an ordinary solution. What is this solution? It is buffer solution. What solution is this? Buffer solution. When you add some acid, it is resisting the change in pH. How it is resisting the change in pH? Let us see. When H plus is added, here you are finding acetate ion. These acetate ions react with H plus, added H plus, and converts into CH3COOH. So these acetate ions are from salt. This H plus are from HCl. So this salt, acetate ions from the salt react with H plus, and converts into acetic acid. And acetic acid is weak acid, it does not dissociate. What happened to H plus, added H plus? Where did they go? They reacted with the acetate ion and converted into acetic acid. And acetic acid, weak acid, it will not release H plus much. Now, no H plus, no added H plus. They were taken by acetate ions. Now there will be much change in the pH. In this way, acidic buffer is resisting the change in pH on addition of acid, small amount of acid. In the same way, let us take when you are adding What you are adding? Base. What you are adding? Base. Now, what are present in this CH3COOH and CH3COO minus and Na plus. These are present. This is acidic buffer. Into this acidic buffer, what is added? Small amount of base like NaOH is added, for example. Small amount. Okay. When a base is added, it will, as NaOH is strong base, it will dissociate completely and it will release OH minus. When OH minus is released, basic nature increases and pH increases. pH must increase. But on looking at this, when OH minus are released from this base, what does this acid do? We are having acid CH3COOH. This acid readily takes OH from the base and converts into CH3COO minus. Okay. Plus H2O. This is acid, base. Actually, if it is NaOH, for example, let me take a very detailed. Okay. NaOH. It will be Na. Salt and water. What happened to this added NaOH? They were reacting with acetic acid and converting into salt. They were reacting with the acetic acid and converting into water, salt. Due to salt, will the pH increases? No. Due to water, if pH increases? No. So in that, this is how they are resisting the pH, change in the pH. This is how they are resisting the change in pH. When you add acid, there is no much change in the pH because acetate ions combined with H plus are converted into acetic acid, and acetic acid is weak acid. It will not further much dissociate. And when add base into it, acetic acid is acid, acid react with base converting into salt. Due to salt, there will be no change in the pH. Due to water, there will be no change in the pH. That is what here you see. Suppose a strong acid is added to the above mixture. The H plus ions added will be taken up immediately by whom? Acetate ions to form very slightly dissociated acetic acid. Feebly dissociated, very less dissociated. It will not release H plus, much H plus, because its degree of dissociation is very much less. In the same way, thus the H plus ions added are neutralized by the acetate ions present in the mixture. There is very little change in the pH of the mixture. Already it was discussed. Buffer solutions, what does buffer solution do? It will resist the change. Though it resists the change, there can be very small change in the pH. In the same way, you see, if on other hand, a strong base is added, the OH minus ions added are neutralized by acetic acid present in the mixture. See, OH is neutralized by whom? Acetic acid to form salt. Okay. Thus, again, there is very little change in the pH of the mixture. So, this is how they are resisting the change in pH to buffer solution. Okay. Next. Calculating the pH of acidic buffer. Acidic buffer. Now let us see. CH3 acidic buffer contains CH3COOH. It slightly dissociates into CH3COO minus plus H plus. Okay. And it also contains what? It also contains CH3COO Na dissociates into CH3COO minus plus Na plus. So here we can say the concentration CH3COO minus concentration is equal to CH3COO Na concentration. What is acetate ion actually? It is these acetate ions are all from the acid. Why? Because acetic acid is weak acid, it does not dissociate much. All these acetate ions are from whom? All means very less number of acetate ions are from acetic acids. Its degree of dissociation is very much less. So the number of acetate ions produced from acetic acid when compared with acetate ions produced from salt will be negligible. These acetate ions are negligible when compared with these acetate ions. So I can take acetate ion concentration is equal to salt concentration. So what is this acetate ion actually? It is the conjugate base of acetic acid. I can write it as what? Conjugate base. Conjugate base of acetic acid. What is the CH3COO minus CH3COO Na? It is called as, it is salt. It is a salt. Okay. So I can take conjugate base concentration is equal to salt concentration, right? Now let me take acetic acid CH3COOH in derivation. We are deriving it. Then what you get? CH3COO minus plus H plus. We know that this is weak acid. For weak acid, if you write Ka, equilibrium constant of acid, then what you get? CH3COO minus concentration into H plus ion concentration by CH3COOH concentration. So now H plus ion concentration can be written as H plus ion concentration is equal to Ka into CH3COOH concentration by CH3COO minus concentration, right? Now what is this? CH3COOH is acid. CH3COO minus is conjugate base. And conjugate base concentration is taken as salt concentration. Whether you write here conjugate base or salt, both are same. Now I can write it as, see, H plus ion concentration is equal to Ka into acid concentration by conjugate base. Okay, conjugate base concentration. Or I can write it as H plus ion concentration is equal to Ka into acid concentration by salt concentration. Both I can write. Either I write this or this, both are same. Okay. Now if you want pH, let us multiply logarithm on both sides. When you apply logarithm on both sides, multiplying logarithm on both sides, log H plus ion concentration is equal to log Ka into acid concentration by salt, right? So log A into B is equal to log A plus log B. Now I can write it as log H plus ion concentration is equal to log Ka plus log acid concentration by what? Salt concentration. Acid concentration by salt concentration. So multiplying minus on both sides. Multiplying minus on both sides. So what do I get? Minus log H plus ion concentration is equal to minus log Ka, okay, minus log acid by salt. Now what I can write? Minus log H plus ion concentration is equal to pH minus log Ka is equal to pKa. Okay, minus log acid by salt. Okay, this can also be written as pH is equal to pKa. I am making it plus, so salt comes up, salt concentration comes up, salt concentration by what you write, acid concentration. So this is Henderson's equation. What equation? Henderson equation. So what is that Henderson's equation to calculate the pH of a buffer solution? pH is equal to pKa plus log salt concentration by acid concentration. So this is a very important formula. Not only this, there are other formulae which are important here. We have problems in JEE main and NEET examination based on this formulas. H plus ion concentration is equal to Ka into acid concentration by conjugate base concentration. Okay, so what is this Henderson's equation? Here you can find it. pH is equal to pKa plus log salt concentration by acid concentration. Are you getting this? So this formula you have to remember. What is that? pH is equal to pKa plus log salt concentration by acid concentration. Next, let us see here pH range in which acid buffer works effectively. So the range of pH in which the buffer solution works effectively is called as pH range. What is pH range? A range in which range of pH actually buffer solution work effectively. Buffer solution works effectively. Okay, and that is what is that? pKa plus 1 to pKa minus 1. What is that? pKa plus 1 to pKa minus 1. pKa 1 to pKa minus 1. When will be this pKa plus 1? We know formula now. If salt concentration by acid concentration is equal to 10 by 1, then let us calculate pH. pH is equal to pKa plus log salt by acid concentration. Salt by acid concentration is given as 10. Then pH is equal to pKa plus log 10. Log 10 is equal to 1. So pH is equal to pKa plus 1. Okay. If salt by acid concentration is, or salt concentration is to acid concentration is 10:1, then we will have pH is equal to pKa plus 1. If salt concentration by acid concentration is equal to 1 by 10, then pH is equal to pKa plus log 10 power minus 1. Then pH is equal to pKa minus 1. Then, so we got pKa minus 1. So this buffer solution works effectively if the salt is to acid concentration is 10:1 to salt is to acid concentration 1 by 10. If this concentration range, in this range, what is that? In this range, salt to acid concentration can be 10:1 to salt is to acid concentration 1 by 10. Okay, in this range only buffer solution works effectively. If these concentrations, in these concentrations, if the concentration is much more, If, for example, salt concentration by acid concentration is 100 is to 1, then buffer solution does not work properly. If salt concentration by acid concentration is, for example, 1 by 100, buffer solution does not work properly. Only in the range of pH is equal to pKa plus 1 to, okay, pH is equal to pKa minus 1. Only in this range of pH, the buffer solution works effectively, works properly. Are you getting that? So that will be asked. The pH range. Okay, next let us see. So up to now we have seen acidic buffer solution. Let us wind the session here. Let us meet in the next session learning about basic buffer solution and buffer capacity. Buffer capacity. Hope so you understood this session very well. Let us meet in the next lecture with the next part of the chapter. Right, thank you.